Hello, Sci fam. It is your boy Nickel, and today we will talk about mutations. So please title your page Mutations. You can see we're going to look at many different DNA sequences, how they get transcribed into mRNA, translated into amino acids, which create our proteins. So let's get started. DNA. Our first DNA sequence that we're going to look at, before we even talk about mutations, let's just practice this process of transcribing the DNA into mRNA. So if we have a T, that's going to get transcribed into an A, C gets transcribed into a G, A gets transcribed into a U, because there's no T in mRNA, we use uracil instead. So T is going to be transcribed into A, C into G, G into C, C into G, G into C, A into U, A into U, T into A. All right. Well, now we need to look at each of these three-letter sequences and figure out what our amino acids are going to be. So first, let's look at AGU. All right, AGU, right there, SER. SER is serine, SER. AGU is SER. Our next three-letter sequence is AGC. Back to the amino acid table, AGC. It's the same exact amino acid, even though it's a different sequence. So we still have serine. All right, our next up, GCU. GCU. ALA, which is alanine. ALA. Next we have UAA. UAA. It's a stop. So that would tell the ribosome, stop this whole process. Stop connecting these amino acids together because that's the end of our chain. So here we have our protein that was created by connecting amino acids together. Amino acids were translated from the mRNA. The mRNA was transcribed from the DNA. All right, so that would be the typical process, but sometimes a mutation can happen. But mutations are really rare. It's a rare change in the DNA, or it can even happen in the RNA actually. So it's a rare change in the DNA or the RNA of a gene sequence. Because remember, this protein is going to give us one of our traits. Okay, so if our trait ends up being exhibited because we have a SER, ALA combination creating this special protein, let's see what happens if we were to have a mutation. So here's the exact same sequence, but instead of this G, let's say that G gets turned into an adenine instead by mistake. There's a little bit of a spelling error, or when those cellular mechanisms go through to edit everything, they accidentally make a mistake. So let's now transcribe the DNA into mRNA. So T is going to create an A on the mRNA strand. C will create a G. A transcribes into a U. T transcribes into an A. C into a G. A into a U. C into a G. G into a C. A into a U. A. Okay. So now to figure out our amino acid sequence, we'll look at these combinations of 3 mRNA base pairs at a time. So let's look and see what we can take from the top. So we get AGU is going to create an amino acid, or the ribosome will find amino acid SER, serine. AGU is also going to get serine. Actually, maybe it won't. Let's look at the table, because that's not the same as what we were before. So there we go. There is where our mutation happened, right here at this position. So let's see what is AGU. Let's dive into our table. AGU. It's actually serine still. Look at that. All right, so our ribosome would still get serine. GCU is going to be the same as what it was above. So that's going to be ALA, or alanine. It's going to connect. Then UAA is still the same, so that's going to stop the ribosome from working, and we have our protein. But if we compare this protein to our top protein, we have SER connected to SER connected to ALA. Those amino acids connect to make the same exact protein. So sometimes the moral of the story is that mutations can have no effect on the protein. It's possible. So if there's no effect on the protein, that means that there's no effect on the traits. Now, if we look at that table, you can see that in some cases, multiple RNA sequences code for the same amino acid. So there is a little bit of variation that can happen without it actually affecting the protein. But there's more. There's another thing that can happen. So let's go back to this G that originally got mutated. And let's go down our line and let's change it to an even different type of mutation. Maybe instead of it being an A, it's going to get mutated into a T in the DNA strand. So let's see what happens if that were to have a mutation from a G to a T. So let's start with the mRNA sequence. Let's transcribe the T into an A, the C into a G, the A into a U, T into an A, C into a G, T goes into an A, C transcribes into a G, G transcribes into a cytosine, adenine transcribes into a uracil, adenine transcribes into a U, A into a, or T into an A, T transcribes into an A again. So we have AGU, AGA, GCU, UAA. So if we go back to our previous sequence, AGU doesn't change, so we still have serine as our first amino acid connected to AGA. Well, that's a new combination, so let's go back to our table. AGA, arginine. So this is going to be a new amino acid sequence, arginine, and then GCU is the same exact one as it was above, so now we have ALA. All right, and then UAA is our stop, so it tells the ribosome to stop working. Now, this protein that we just created is actually going to be different because it now has this arginine in it, which is a different combination. These three things are combining to make a different protein than what we had above. Before we had SER, ALA. Now we have SER, ARG, ALA. So it's a new protein. So the moral of this story is that mutations can sometimes change the protein, aka the trait. So the reason that we went through these three examples is because really what I want you to take away from this is that when there's a mutation, mutations are rare, but when they do happen, mutations can result in a new trait that is either positive, it can help the organism, it could hurt the organism and give it a trait that's not going to be helpful for surviving in life, or it might just be neutral. It might not affect the organism at all. And also, some mutations can change the amino acid sequence and make a new protein, but some of them don't even affect the protein that's created. So there you have it. Some mutations are positive, some negative, some neutral. Mutations are rare, but when they do happen, this is how it happens. The DNA or mRNA sequence is changed, which then causes the ribosome to read a whole new message.